Okay, so on this page, we have a question at the beginning. Calculate the pH of a solution of sodium hydroxide of concentration 0.05 mole per dm cube. Okay, so first of all, we have to know sodium hydroxide is a strong alkaline. It's a strong alkaline. Strong alkaline, like strong acid. If you remember on page 1 just now, strong acid, the concentration of acid equal to the concentration of the ion. That means equal to the concentration of H+. So for strong alkaline, the concept is just similar. The concentration of sodium, okay, maybe I write formula lah. The concentration of NaOH is equal to the concentration of the OH minus. Okay, same one. So because of that, the concentration of hydroxide ion is equal to 0.05. So why they are same? Because they completely dissociate. So because of that, they are same. Okay? The concentration are same. Once you get the concentration of hydroxide, right, we can do the next step, POH. POH equal to negative log OH, which is negative log 0.05. Then press calculator. Then you get 1.301. You get POH. When you get POH, then you use the formula 14 equal to pH plus POH. And after that, you will get 14 equal to pH plus 1.301. So you get pH equal to 12.7. 12.7. Okay, so what am I going to say is this working is much more similar compared to the weak base just now. Much more easier. Okay, much more easier compared to weak base. So you must memorize the working. Weak acid, how is the calculation to get pH? And then strong acid, how is the calculation to get pH? And then weak base, how is the calculation to get pH? And finally, strong alkaline, how is the calculation to get pH? So altogether, we have, so far until now, we have four sets of calculation method where you need to remember one. Yeah, so weak acid, strong acid, weak alkaline, and strong alkaline. Four sets of calculation method. So you must memorize it. Okay, so we move on. So calculation for pH, settle ready. So this is something else ready. Buffer solutions. Okay, for buffer solutions, first of all, we need to know what is that. Let's say a solution. A solution in which pH doesn't change significantly when small amounts of acid or alkaline added. So example is like in our human body. Okay, our human body, in our blood. Imagine that when you drink or when you eat, let's say, for example, you drink Coca-Cola, okay, so which is acidic, but it doesn't really change your pH of the blood, okay, because there is a buffer system in your blood, okay, which can resist the change. So that is the functions of buffer. Buffer solution, as in the blood is a buffer system also. So the pH doesn't change because there is something which neutralize it. Okay, if you add acid to it, there is something that neutralize it, and if you add alkaline to it, then there is something that neutralize it. So that is the usage of buffer solution. Now you see the second point here. A buffer solution can be acid. That means acidic buffer solution. This is the first type. Okay, acidic buffer solution. Or the second type is alkaline buffer solution. So there are two types of buffer solution: acidic buffer solution or alkaline buffer solution. So now let's come back to acidic buffer solution. How to make an acidic buffer solution? We have to learn it now. So you have to use a weak acid. Cannot use strong acid. Weak acid and its salt. What is mean by its salt? That means imagine this weak acid you neutralize by alkaline. What kind of salt are they going to form? So try to imagine it that way. So that is the salt of this acid, not the salt of any acid, So it's the salt of the same acid. Okay. Or example, like the weak acid that we use is ethanoic acid. So this ethanoic acid, the formula should be COOH. One O is missing. One O is missing. COOH. Okay. That is the weak acid, and the salt, right, must be the salt of the ethanoic acid. Cannot be any salt, Cannot be, let's say, NaCl. Can I use NaCl? No, cannot. Must be the salt of this acid. So you just imagine this acid, you react with alkaline, then they form CH3COONA. This is the salt of that acid. Okay, so we have to know something about this CH3COONA also. Then you will understand why these two can act as a buffer solution. So a buffer solution resists the change in pH. Resist the change, how it works. So let's say I start from here first. Ha dissociates, become H plus N ions. So if the weak acid that I use is ethanoic acid, so it's going to be CH3 COOH, dissociate to become H plus CH3 COO minus. So where over here, it is good to know it to understand it in this way. So first, this ethanoic acid is a weak acid. So it is a weak acid. When it forms ions, they form small amount of ion. So for example, you have 5% dissociation. Okay, only 5%, and 95% remain as molecule. So the amount of ions is very small. Okay, so if the amount is very small, then what kind of problem do we have? So the problem is you have to know that to act as acidic buffer, right? We need somebody to neutralize the acid that add to the acidic buffer. We need somebody to neutralize that. Okay, we need somebody who is going to neutralize the acid when acid is added to the buffer. Okay, so we need to know who is going to do that. Or when alkaline is added to the buffer, who is going to neutralize it to avoid the change in pH? They must have somebody who take that role, so that the pH remains the same, okay, or more or less the same. Okay, so who is going to do that? So over here, logically, you know, this is ethanol acid, right? So acid can react with alkaline. That is something that we know long time ago. So because of that, what am I trying to say is, if you have alkaline added to the buffer solution, who is going to handle this? This is your guest, you know. So this is your, I mean, for example, this is your customer. Okay, this is your customer. Who is going to entertain this customer? So of course, the acid is going to handle it. The acid, we have plenty of acid here. No, 5% dissociate only. So 95% of ethanol acid is here. We have plenty of acid, which can go and neutralize the alkaline added, so that the pH doesn't change. So we have acid. So this one, I write down first. The CH3COOH is going to, the role of this thing is neutralize the alkali added to the acidic buffer. Okay. Ethanol acid is in charge of doing that. Neutralize the alkali added to the acidic buffer. Okay, so that is one thing you know already. Okay, so if the buffer solution has alkali added to it, then ethanol acid is neutralizing it to avoid the change in pH. Okay, so settle already the alkaline settle, but now acid. If acid is added to the buffer, who is going to entertain this customer? Your acid is the customer now, let's say, okay? Who is going to entertain this customer, or who is going to neutralize the acid? So it is done by this thing. It's done by this thing. Huh? Who is this actually? This is ethanol acid which ionized to ethanoate ions. These ethanoate ions have something special, So we have to take it in this way. It has something special. This is acid. Ethanoic acid is acid. So we know long time ago. This ethanoic ion, right? There is a name to name this. It is known as conjugate base. Conjugate base. Huh? So what is conjugate base actually? Conjugate base, right, is a base. It's a base. It acts as a base. Okay, it's just a base. What is mean by a base? Base means proton acceptor. Proton acceptor. And if I say it is a base, it's a common, I mean, if it's a base, it's a proton acceptor. So something reasonable or something logical should come out in this way. This is a base because this one can easily accept H plus to form ethanol acid molecule. So this one can act as base because they can accept H plus. So it's a proton acceptor. So that's why this is a base. Okay, this is a base. And if this is a base, right, its role is neutralize the acid added to the acidic buffer. Okay, so from here we understand something. We understand that when you add small amount of acid, the ethanoic ions, which is a conjugate base here, will go and neutralize the acid added. And then the buffer will have no change in pH. Okay, so that is another problem. The problem is the amount of ethanoic ions here is 2 liter. 2 liter. 2 liter because, like what I said, ethanoic acid is a weak acid. 95% remain as molecule. Maybe 5% dissociate. Very small amount of ethanoic ions over here. And because of small amount, right? Okay, so we have to add this salt inside. Okay, you use ethanoic acid to act as buffer alone, not enough, because we don't have much amount of ethanoic ions. It dissociates partially only. So to overcome that issue, we add ethanoic salt into water. You know ethanoic, sodium ethanoic, yeah. So it can easily dissociate. It can 100% dissociate because sodium salt can 100% dissociate. So this supply CH3COO minus. Okay, so I write down first. The role of this thing, the role here is to supply CH3COO minus. That is the role of the salt. Supply CH3COO minus so that the CH3COO minus can neutralize the acid added to the acidic buffer. So that's why we need two of these to work together as an acidic buffer. So this one will go and neutralize the alkaline added, and this one will go and neutralize the acid added. Okay, so yeah, now already explained everything. Now let's see the alkaline. We look at it later. Okay, let's see the equation first. The equation. If you are wondering what equation is this, maybe I can explain now. It's the time to explain this. So this one I already explained. This one, this equation, I already give it here. And how about this? This one. This one is actually maybe I should pull it up here. Okay, so I pull up here as my example. Yeah. Okay. Your salt CH3COO-Na. The Na is the M here, the metal. The metal is the Na. So they will dissociate to M plus and N ions. So the M plus is the sodium ion. They will fully dissociate because sodium salt is soluble, soluble salt. So they will form Na plus, where it is the M plus in the note, and CH3COO minus. So that is how we understand this equation. Okay, so now let's see how they neutralize the acid added and how they neutralize the alkaline added. So we look at the next page first, or the right hand side. The right hand side, 3.5. Working of an acidic buffer. Okay, so now let's see. HA dissociate become H plus and A minus. Okay, so example, this is the equation. This is the equation. Yeah, this is the equation. So the acid dissociate to H plus and CH3COO minus. Okay, so as in here, this one is similar to that. If you add acid to this acidic buffer, or maybe before that, the acid, like what I said, is a weak acid. So we have a lot of molecule available, but we have very little of ions. And because of that, we add some salt. We add some salt, as in here we add this salt to supply more A minus. So that's why you see here high concentration due to salt dissociating. Our salt dissociate to this and this. This thing supply large amount of A minus, the anion. Supply large amount of A minus because of from the salt. From the salt. Okay, so now you have large amount of A minus, you have large amount of acid also. So if you add acid to the acidic buffer, then the conjugate base is going to neutralize it, the conjugate base. And what equation should you write is the acid added is H plus. The conjugate base, go and neutralize it, is A minus. And this H plus added from outside to the acidic buffer is combining with the A minus to form HA. Okay, so example here, the role of CH3COO minus has been written down here, is to neutralize the acid added to the acidic buffer. So if there is acid added, then what happens is the H plus will react with the CH3COO minus in the buffer solutions. CH3COO minus in the buffer solution, and then they will change to CH3COOH. So you must remember this equation because they like to ask. Like, write down the chemical equation when acid is added to the acidic buffer. Then you have to write this equation. Then they give you 1 mark. Okay, so now let's move on. Okay, let's see the words here. Adding acid increases H plus. So you add acid to the acidic buffer, of course the H plus concentration increase, and large amount of A minus present react with the H plus added. That means the CH3COO minus will go and neutralize the H plus. Your H plus is the customer that I said just now. When H plus is added, who is going to entertain this H plus? The A minus will go and entertain it, combine with it to form the acid molecule. Equilibrium move to the left. So move to the left, something like this. This plus this move to the left. So if you add alkalines to the acidic buffer, who is going to neutralize the alkaline? So of course it is this guy. This is acid. Acid is going to react with the alkaline added to the acidic buffer. Okay, so now you see here, the acid from here, the ethanol acid for example, neutralize with the hydroxide ion added to the acidic buffer. Then you get H2O plus A minus. So which means neutralization, something like neutralization. Okay, so example, let's see the equation here. If you have OH minus added, who is going to neutralize it? So it is the acid. CH3COOH will react with the hydroxide ions to form H2O and to form CH3COO minus. The equation will be like this. So altogether there are 3 equations. A, B, and C. Okay, so the exam question like to ask these 3 equations, so you must be careful. Let me highlight one by one. When should you use equation 1? When they say write the equilibrium equations of the acidic buffer. Then you write this equation. Okay. So when should you write equation B? When the question asks, write the chemical equations when alkali is added to the acidic buffer. Then you write this equation. And when should we write this equation? We write this when they say write the equations, write the chemical equation when acid is added to the acidic buffer. Then you write this equation. Altogether, there are 3 equations to remember. Okay, so that is all about acidic buffer. We have done acidic buffer. Okay, so we just move on. Of course, if you are wondering how to prepare acidic buffer, I draw a simple diagram. So just a simple one. You prepare a beaker, for example, a simplified version. You prepare a beaker. You add first. You add CH3COOH to it. You add CH3COOH to it. Okay. Then, of course, this is ethanoic acid. You add ethanoic acid to it. That is not enough. It is not acidic buffer yet. Number 2, you add CH3COONA to it. You add CH3COONA to it. So after that, of course, you have to stir it, stir, and get acidic buffer. Okay, so that is how we prepare. The acidic buffer. Okay, so we will have calculation involving this. It is not just add this, and stir, then you get acidic buffer. We will have calculations on the next page. Okay, on the next page, like how much acid should you add, how much salt should you add, then what is the pH of this acidic buffer. You will have calculation like that. When you add hydroxide to it, what is the new pH? The pH will increase in a little bit. When you add acid to it, what is the new pH of it? The pH will drop a little bit. Have calculation. So we will handle that later. The calculation is very complicated, So, but now it is just theory. The theory is you add this acid, you add this salt, you stir, they mix together, then that is acidic buffer. So settle already, acidic buffer. Now let's talk about alkaline buffer first. Or alkaline buffer, or basic buffer also can. Now let's see. Alkaline. Weak alkaline plus its salt. For example, ammonia plus its salt, ammonium chloride. So the explanation is more or less the same one. Let's see, we do a quick one here. Then we have 3 equations also. Okay. So maybe, I change my mind. I write on the left. I keep some space for that side. Okay, so let's say A, ammonia. Ammonia, the equilibrium equation, you have to write H2O. Then they become NH4 plus OH minus. So the ammonia, of course, is an alkaline, or you can also call it base. Okay, that is ammonia. And alkaline and base means proton acceptor. So they tend to accept protons to form ammonium ion. So they are alkaline and base because they can accept proton. So once they form ammonium ions, this ammonium ion is called conjugate acid. Conjugate acid. So what is meant by conjugate acid? Conjugate acid means it is an acid. Acid means what? Acid means it is a proton donator. Imagine ammonium ion has one extra H plus over here. It can easily donate away the H plus and form back ammonia. So it is a proton donor. Conjugate acid here is a proton donor. Okay, so their role is the same. The role of ammonia is, okay, so before we talk about the role, let's say how we prepare. How we prepare the alkaline buffer. Number one, add NH3. Okay, add NH3. Ammonia solutions. Okay, you add ammonia solution. Okay, so the problem is ammonia is a weak alkaline. A weak alkaline doesn't dissociate much to the ions. Doesn't dissociate much. So in order to have a lot of conjugate acid, right? So we have to add ammonium chloride. Have to add ammonium chloride. So the second step is number 2, we add ammonium chloride. Okay, when you add ammonium chloride, so what happened then is we have large amount of ammonium ion and we have large amount of ammonia molecule. Ammonia molecule a lot because it doesn't dissociate a lot. It still remains as molecule. And the ions is very little at the beginning. But you add ammonium chloride to increase the amount. So at the end you have large amount of base and large amount of conjugate acid. Both have large amount. So number 3, same like the above. Stir and get alkaline buffer. Okay. So now let's talk about their role. Their role, kind of reasonable one. This is alkaline, right? So their role is neutralize the acid added to the alkaline buffer. This is their role. Okay. So what is the role of ammonium ions? The role is neutralize the, it's acid, right? So that means neutralize the base. The base added to the alkaline buffer. Yeah, this is their role. And because of that, we need to know the equation. Okay, we need to know the equation. To find out the equation, let's see the note, which is here, 3.6. Okay, you can see here, the alkaline dissociates to form a positive ions. It's not metal. Okay, it's not metal. Okay, so for example, it's ammonium ions plus hydroxide ion. Okay, so ammonium ions is in small quantity initially, so that's why you have to add salt to increase the concentration of the ammonium ion. And now you prepare your buffer, your alkaline buffer already. Now you can add acid to the alkaline buffer to see whether the pH change or not. So the pH is not supposed to change a lot, okay? Because buffer solution, the function is to resist the change of pH. Okay, so the equation is when acid is added, the alkaline here is going to neutralize with the acid to form water and the salt. Okay, the ammonium, you know. So adding acid increases the hydrogen ions. So large amount of alkaline presence. This is the alkaline. Because it doesn't dissociate, right? It remains as molecule, so that's why large amount. So we react with the acid added, and equilibrium move to the right. So they move to the right to form a lot of M plus. Okay, so let's come back here. If that is the general statement, how we apply it in this example. So if H plus, so if H plus is added, the equation is the ammonia will react with the H plus to form. Just now the equation said water and M plus, but we can't form water here because of no oxygen. So we just form NH4 plus will do already. Okay, so that equation in the note is general equation, but for this case, ammonium ion will do already. Okay, so the H2O just ignore it. So this is the equation that you have to remember when acid is added. Who is going to neutralize it? So the alkali is neutralizing it, and the equation is like this. So let's see the notes again. On the other side, if alkaline is added, okay, as you can see here, if alkaline is added, the conjugate acid is going to neutralize it. So the conjugate acid neutralize with the alkaline added, then they form salt. Okay? They form salt. So MOH, okay, MOH, they combine, the positive ion and the negative ion combine. So adding alkali increases the OH minus concentration, and large amount of conjugate acid present to react with the OH minus added, and equilibrium move to the left. Move to the left. Move to the left to form MOH. Okay, let's say example for our case here. So if we have OH minus added, I call it equation C. So who is going to handle it? It is ammonia. Ammonium ion. Ammonium ion will go and neutralize the OH minus added, and then they will form ammonia plus H2O. So the equation wrote MOH. So for my case here, MOH is not so suitable to be used here. You can write NH4OH. It's up to you actually. So NH4OH if you want to match with the theory just now, MOH. They found MOH. So if you want to write that, it's okay. But at most of the time, we will write this instead. NH3 plus H2O. Okay? Which is same with this one actually. Same one. Okay, so we write the equation in this way. So from here, we know alkaline buffer has 3 sets of equation as well. So we have done alkaline buffer. Now we move on. Okay, so this is example how buffer works over here. So where we can see buffer is in our blood. So first you see respiration in cell produces carbon dioxide. You know, carbon dioxide is formed, right? Yeah. When the cell go through respiration. And carbon dioxide combined with water in blood. See, carbon dioxide combined with blood, combined with water in the blood, then they form H plus and HCO3. Carbonic acid lah, basically. H plus and HCO3. Just now I mentioned carbonic acid, right? It is H2CO3. H2CO3, yeah? Okay, so carbon dioxide dissolve in water to form H2CO3. So equation A, H2CO3 dissociates to form H plus HCO3. You know, the buffer always have three equations, so I try to make it in a similar way. So the equilibrium equation is like this, or you can write like this, it's up to you. So either write this form or write this form, it's up to you. Both will be accepted. So we continue. The enzyme carbonic anhydrase is present to supply HCO3 minus ions and increase its concentration, similar to acidic buffer. So they are trying to say this is a weak acid. It dissociates partially. So the amount of ions is very little. And because this amount is very little, right, the enzyme work on that. The enzyme work by producing a lot of HCO3 minus ions. Okay, increase the amount of this. How it works, no need to care one. So you just need to know at the end what happened. At the end, what happened is the amount is a lot. This ion has a lot. Okay, has a lot because these enzymes act to produce a lot of this. Okay, so what is so important about this ion? So similar to just now, this is the acid, this is the conjugate base. Conjugate base is actually a base. So now, if our blood has H plus increases, that means let's say you drink Coca-Cola, okay? You drink Coca-Cola, become acidic, so or you eat food with vinegar, acid increase. So at the end, equilibrium shift to the left. How? What happens? What equation? Okay, equation will be like this. If you add acid, the equation same like this one. If you add acid, then the equation is like this. Okay, the acid will react with the conjugate base to form the acid molecule. Okay, let's say I call it C. If you add acid, okay, so if you add acid, then the acid will react with the HCO3, which is the conjugate base, to form H2CO3. Okay, equation B. Here, if H plus decreases, let's say you eat something which is very alkaline until this concentration decrease, equilibrium shift to the right to increase the H plus concentration. Okay, so what happened here? This is similar to our equation just now. Let's take a quick look. Equation B. If alkali is added, the acid molecule react with the hydroxide ions to form water and an ion. So it's just similar. If OH minus is added, then the acid will go and react with the OH minus. Then they will form water and HCO3. So these are the three equations. And because of that, the pH of blood remain unchanged because of this buffer solution. So the pH remain unchanged. Okay, so settle for this page. Okay, so let's look at these questions. The phosphate buffer system operates in biological cells. The buffer contains dihydrogen phosphate, H2PO4-, which act as a weak acid. So H2PO4- react with water, become HPO4 2- plus H3O positive. This is the equilibrium equation. Okay, write an expression for the Ka of H2PO4. So you know Ka, they don't want to see H2O. So when we write the equation, we just write like product over reactant. So concentration of HPO4 2-, concentration of H3O plus. Okay, so concentration of H3O plus, then divide by the concentration of the reactants. So like what I said, we have two reactants here. We don't want water, we just want the other one. So we just put the other reactant at the bottom, H2PO4-. Okay, so this is the Ka. The Ka. Now, B part 1. Explain what is meant by the term buffer solution. Okay, so this one is the definition. You have to remember it. A solution that resists change in pH. So this one mark already. When small amounts of acid and base or alkaline, up to you, are added. So this is the definitions of buffer. Now let's look at part 2. Write two equations to show how solutions containing a mixtures of H2PO4- and HPO4 2- act as a buffer. So that means you have the right equation when acid is added, and you have the right equation when base is added. So in my notes, I call it equation B and C. The equation here is equation A. In my notes, I call it A. Then now they ask you equation B and C. So how? So we can just put like this. Addition of acid. So you have to know that this one is an acid. So this is the conjugate base. This is an acid. How we know? Because it's written here, weak acid. So the other way to know is the one with more hydrogen is acid. This one have more hydrogen. This is acid. This one has less hydrogen. This is conjugate base. So I write down. This is acid. This is conjugate base. Okay. So when acid is added, who is going to handle it? Of course, it is the conjugate base. So the H plus will react with the conjugate base. Then they form the acid again. Okay, so addition of base. So addition of base, who is going to handle it? Of course, the acid is going to entertain with this customer. Okay, so which means the acid H2PO4- is going to handle with the hydroxide ion. Neutralize it, which means so what they form? They will form HPO4 2 minus plus water. So the theory part is just like that. So